Good morning everyone, welcome to Gate Academy Global. If audio and my video is perfect then just confirm me. If audio and video both are perfect then just confirm me. So today we will discuss problems from the combinational circuit. Okay, in today's class we will discuss problem from the combinational circuit. Just confirm me my audio and video both are clear or not. Okay, just confirm me my both audio and video both are perfect or not. Okay, so in today's session I will discuss many number of previous year questions. Okay, anybody just confirm me. Yeah, good morning. Good morning Krishna. Audio and video is fine. Okay, thank you very much. Okay, so in today's session we will conduct many number of questions from this previous year booklets. Okay, I hope ki many of you have previous year questions, and if you don't have I will take, don't worry. Okay, but you should have previous year question book. Okay, so first question I am going to start. That is from the very basic. So some question will be from multiplexer, some question will be from the adder, some question will be from the decoder, some question will be from the logic gate. So from the whole topic in today's session I will conduct questions. Okay, now so from the whole topic I will conduct the questions. So just note down first problem, and this is very simple problem. Okay, now here one XNOR gate is given like this. One XNOR gate is given in this way. Okay, one more XNOR gate is given like this. One more XNOR gate is given like this. Two XNOR gate is given, and again this both output is passed from XNOR gate. This both output is passed from XNOR gate, and what they have provided, this is A and this is B bar, and this is A bar and this is B. Clear? Now what examiner asking, what will be this output? What will be the output function? So four options I am going to provide you. First option is 0, second option is 1, third option is A bar B plus A B bar, and option D is A XOR B whole bar XOR with A XOR B. These four options they have provided. Just you should try to solve by yourself first. This is a 1995 gate question. I will conduct all the previous year question in today's classes. Okay, just you should try to solve and tell me the answer. Then I will solve. First you should try by yourself. Okay, so let's see how we can solve this kind of question. If you are expert in properties of XOR XNOR, if you are expert, then how you can solve? You can write this directly. Can I cancel this bubble and this bar? Can I cancel? Or you can write this thing is nothing but A XNOR B bar. Can I write? And this thing you can also write. This B bar, if you will change, you can write A XNOR B whole bar, and whole bar and one XNOR gate you can again change. This is nothing but A XOR B. Already we are expert in properties of XOR. Now here you can also write this is nothing but A bar XNOR B. Can you write? And you can also write this is nothing but A XNOR B whole bar. This single bar you can convert in whole bar, and one whole bar and one gate you can easily convert. This is nothing but A XOR B. So this is A XOR B and this is A XOR B. A XOR B and this is A XOR B. So this is nothing but A XOR B and this is nothing but A XOR B. So same quantity. Suppose you are considering this is X, then this will be X. So X XOR X whole bar. What will be the output? A XOR B XOR A XOR B whole bar. Or you can also say this is nothing but XNOR. You can say like this, A XOR B whole XNOR. Same quantity. If you are saying this is X, this will be X. So X XNOR X. What answer you will get? X dot X plus X bar into X bar. Same quantity XOR. If X can be 0 or 1, always you will get answer 1. Always you will get answer 1. Clear this thing? So answer will be option B. Answer will be option B. Clear this thing? Answer will be option. This is very simple thing. So just you have to convert this bar and this XOR to XOR. It will save your time. It will save your time. Clear this thing? It will save your time. Clear? Now my next question. Now my second question. So I hope this question anybody can solve after my all the classes. Anybody can solve this question within 30 seconds. Within 30 seconds. Clear? So if you are expert, you can cancel this bubble and this bar. You can cancel. So if you don't know this thing, you should remember this. If you are getting this kind of suppose X naught, if this is A and this is B, if you want to remove this, bar, anyone can be here bar. Anyone can be here bar. If here B bar was present and if here bubble are present mean not, you can cancel this not, this not with this bar. You can cancel. Always try to convert all the X naught to XOR. Always you should try. Problem will be easier. Problem will be easier. Okay. Next question I am considering. So here answer is option B. Option B is 1. Next problem. Next problem. Okay. So you should be expert in these things. You should be expert in this thing. Now the next problem. Okay. Next problem I am considering. Again one good question, but one very basic question. Next problem. One multiplexer is given. Okay, this is 8 cross 1 mux. One multiplexer is given. Here total input is x0, x1, x2, x3, x4, x5, s6 and x7. Total this is the 8 input, and multiplexer you know only one output, that is suppose they have provided us a y. Here one enable, this is enable, and this is active low enable. And here three selections line. This selections lines is S2, S1 and S0. There are three selections line. This is A, this is B, and here C. This is passed from the OR gate. This is C. And second terminal is open. And here this enable is connected to many one. And this enable is connected to first X1. This is connected to X1. Second, this is connected to X2. Next, this is connected to X4. Next, this is connected to X4. And next, this is connected to X7. Clear? Remaining X0, X3, X5 and X6. This X0, X3, X5 and X6. This all are the one. This all are connected with one. And this is connected with a 0. Clear? So enable is connected with 0, means this circuit is always enable. So this circuit is working. This circuit has been given, and here they have provided this is a TTL gate. Means this OR gate is designed by TTL, and you know very well floating input concept in TTL gate. So this input is given here open. This is open. You cannot treat open as a 0. In previous classes already we have studied, in the TTL gate open input or floating input is treated as logic 1. So you should remember this. Floating input or open terminal in TTL is treated as logic 1. So you can put here 1. In question they have not provided. So you can treat this as a 1. Can you do? Now what will be the output y? Okay, now y is 4 options I am going to provide you. First option, indeterminate. Indeterminate means you cannot find out. Second option they have provided A XOR B, A XOR B. Third options they have provided A XOR B, and last option D they have provided C bar A XOR B whole bar, A XOR B whole bar plus C A XOR B. This kind of 4 options they have provided us. This kind of 4 options they have provided us. Okay, this kind of 4 options they have provided us. So here this concept should be very important. Here this concept should be very important. Floating input is treated as 1. So this 1 plus C, this will be always 1. This will be always 1. This will be always 1. What will be the output of multiplexer? So why directly can I write? What directly you can write? C bar, B bar, A bar. You can write in this way. Okay. You can write in this way. 0, 0, 0. X0 will be selected. And this is multiply with 1. This is multiply with 1. So what can I write here? This bar, this bar, this bar. So right now I am going to write C bar, B bar, A bar. C bar, B bar, A bar. And this is multiply with X0. X0 is 1. This is 1 plus. What will be the second? You cannot write this C bar. This is 1 bar. So can I write this is 1 bar means 0. Can I write? What will be the second term? So if you can see here, first 4 terms are 0. 0, 0, 0, 0, 0, 1, 0, 1, 0 and 0, 1, 1. So this 4 term, what you can write? Multiply with 0. Sorry, this 4 term, just wait. This is C plus open terminal and you can write this is 1. This is 1. Okay, this is 1. So what you will write if this is 1 bar? 1 bar means this will be 0. 1 bar means this will be 0. 1 bar will be 0 if you will multiply any term with 0. If you will multiply any term with 0, then you will get a result 0. So first 4 term you will not get answer. First 4 term. You will get a 5, 6, 7, 8. 5 means 1, 0, 1. 1, 0 means this is 1, this is 0, this is 1. So directly 5, 6, 7, 8 I am going to write. 5 means this is 1 and this is 0. 0 means B bar and this is 1 means A bar. So 1, B bar, A bar, multiply with this is 0, 1, 2, 3. Multiply with X4. X4 is nothing but 0. So again this is multiply with 0 plus. So this term will be again 0. Next term 1, 1, sorry. This is sorry. This is we have considered 1, 0, 0, 1, 0, 0. 1, 0, 0, B bar, A bar. That is correct. Next 1, 0, 1, 5. 5, this is 1. And this is B bar and this is A. 1, 0, 1. Yes. Okay. And then this multiply with X5. This multiply with X5. And X5 is nothing but 1. Here X4 was 0. And here X5 is 1 plus. So just you have to consider 5. You have to consider 4, 5, 6, 7. You have to consider here 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1. This 4 term you will get only answer. So this is 4 we have considered. This is 4 na? And this is 5. This is 5. Now next one is 6, 1, 1, 0, 1, 1, 0. What we can write? This is 1 and this is 1 and this is 0, A bar. 1, 1, 0 and that is multiply with X6. X6 is nothing but 1. Again the last term 7 and that will be multiply with 0 means you will get answer last term is 0. What will be the last term? 1 into B into A into 0. So this term will be 0 and this term will be 0. What answer you will get? Y is equal to A bar B plus A B bar. This will be the answer. This will be the answer. This will be the answer. Okay. So 4 options they have provided and this is nothing but A XOR B. A XOR B. This is the answer. So here just you should concentrate on the open terminal. But you have to again concentrate examiner have provided TTL or not. If they have provided ECL. In ECL open input is treated as logic 0. You should remember. If TTL floating or open input is logic 1. In ECL floating or open input is logic 0. In CMOS you cannot say. If examiner will change this is CMOS. Suppose CMOS, then answer will be this. Then answer will be this. In CMOS circuit, you cannot treat any input as a open circuit. Circuit will practically not work. This thing you should remember. So this is a previous year gate question. If examiner will ask same kind of question, this question has been asked 2 times in gate exam, same kind of question. But now if this year, if examiner will target this question, most of the chances they can provide you CMOS. They can provide you CMOS, and this result will be indeterminate. Indeterminate. Clear this thing? Now, clear this thing? So now I have considered 2 very basic question. First question from the property of XOR and XNOR, and second question from the floating input concept. Multiplexer solution is very easier. Just you have to write the output function. Just you have to write the output function. Okay. Now next question. Next question I am considering from the delay circuit. Next question I am considering from the delay circuit. Okay. Just next problem. Okay, next problem we are going to consider from the delay circuit. From the delay circuit. Okay, now, and this is from gate 2016. From gate 2016. Okay, just note down the next problem. Note down the next problem. Okay, now here 2 multiplexers is given. First multiplexer and this is second multiplexer. These 2 multiplexers are given like this. Here these 2 multiplexers are given, okay, and both are 2 cross 1. This is 0 1 and this is 0 1. This question from 2016, and you can mention here 5 star. This is a very good question, and if you will learn many concepts from here. Here one NOT gate was present, and here one NOR gate was present, connected with 0. This is connected with Q, and this second terminal is connected with R. And this is S, and here this is selection line S0 and this is selection line S0. S0 is connected with T like this, in this way, and here one NOT gate was present like this. This is your selection line, clear? And selection line is connected to T, first multiplexer T and second multiplexer T bar. And now this output is divided in 2 parts. And this is connected to 1, this is connected to 1. Here again one NOR gate was present, and this second input is nothing but a P. This second input is nothing but P. So P, Q, R, S, T. 5 inputs are present here, P, Q, R, S, T. And this complete output is Y. This complete output is Y. This circuit is given. All are this multiplexer. This is 2 cross 1 mux. And this is 2 cross 1 mux. This circuit is given. Okay. Now examiner have also provided here inverter NOT gate delay, propagation delay of NOT gate is equal to propagation delay of NOR gate. First I am considering NOR gate is 2 nanosecond. This NOR gate and this NOR gate delay is 2 nanosecond. Second they have provided multiplexer mux delay is 1.5 nanosecond, 1.5, and the NOT gate delay is 1 nanosecond. So this NOT gate delay 1 nanosecond, this multiplexer 1.5 nanosecond, and this multiplexer 1.5 nanosecond, and this NOR gate having 2 nanosecond, and this is 2 nanosecond. This thing they have provided. And now they are asking what is the maximum propagation delay. What is the maximum propagation delay? So here 2 questions I am asking you. What is the maximum propagation delay and what can be the minimum propagation delay? But examiner asking maximum propagation delay is equal to question mark. Clear this thing? Here maximum propagation delay is a question mark. So we have to solve this question. This is a very good level of question. Okay. Now if you can solve this question, you will be very much comfortable in delay problem in combinational circuit. So this is the best problem from the delay in combinational circuit. So here you can see, first you can see P, Q, R, S, T are the input. are the input. I am going to write question. Okay, I am going to read out one question. For the circuit shown in figure, the delay of NOR gate, multiplexer and inverter are given if all the input P, Q, R, S, T are applied at the same time. This is the important thing. P, Q, R, S, T are applied at the same time. At same time all 5 inputs are applied, then what will be the maximum propagation delay of the circuit? Clear this thing? What will be the maximum propagation delay of the circuit? So P, Q, R, S, T, they are providing at the same time. That can be anything, that is your choice, but the maximum delay, how much maximum delay can be achieved by this circuit? So let's see how we can try to solve. So here two multiplexers are given. Now you can see this is connected with T and this is connected with T bar, and T can be anything. If T is 0, so if this is 0, this will be selected, and if this is 0, this will be 1, and if this will be 1, this will be selected. Means what will be your path? Your path will be like this, from here to here, then here to here, like this. This is the first path. So first you have to find out the number of paths, and if T is equal to 1, if this is 1, then this will be selected, and if this is 1, this will be 0, and if this will be 0, this will be selected. This is the second path. So first you have to find out the number of paths. So how many number of paths here? Number of paths. Can I say 2 paths can be possible here? First path, and path will be decided by T. So we have to consider here 2 cases. One for T is equal to 0, second for T is equal to 1. So case number 1 I am considering. Case number 1, if T is equal to 0, can we consider? If T is equal to 0, then this is 0, and this will be 1. So here this input will be selected, and here this input will be selected. Clear the thing? Now you are applying all P, Q, R, S, T at the same time. So now you have provided P, you have provided Q, you have provided R, you have provided S, and you have provided T. All 5 input, and T is nothing but a 0. So if you are going to provide here 0, this input will be pick. Now we are assuming initial this was 0 or initial this was 1, and when you are providing input, this will trigger, means this will work, and this will modify this output. Initially it can be 0 and initially it can be 1, but we are assuming this will going to modify this output. So if you are going to provide this QR, this will change this output. So suppose I am going to assume this output is X. After how much time you will get? 2 nanosecond. Then this T you have provided at 0 nanosecond. This will be peak. When? After 2 nanosecond. Then after this delay means 1.5 nanosecond, you will get here X. So when you will get here X, after 2 nanosecond and after 1.5 nanosecond means 3.5 nanosecond. Now if this is 0, this will be 1. When this will be 1? After 1 nanosecond. So after 1 nanosecond, this multiplexer will start to work, and you are getting here X after 3.5 nanosecond. That can be synchronized. Yes, that can be easily synchronized. This is available after 3.5 nanosecond, and this is going to start at 1 nanosecond. That can be synchronized. If this was 4 nanosecond, then this input you received at 3.5, but this multiplexer is going to start at 4. So you will consider 4 delay first. Then 4 plus this delay, you will get the answer. So always this delay should be less than this delay. So here that's why examiner have provided this is a 1 nanosecond. So circuit will be fully synchronized. So this second multiplexer will start to work after 1 nanosecond, and you are getting here X after 3.5 nanosecond. Yes. So this X you are getting here at 3.5 nanosecond. Clear? Now after this delay you will get Y. So case number 1, if T is equal to 0, what will be the output? You will get output pass from this NOR gate. So first delay you will consider for this NOR gate plus this NOR gate. You can also say this is NOR gate number 1 and this is NOR gate number 2. This is MUX 1 and this is MUX 2. In this question, examiner have provided both the NOR gate having same delay, both the multiplexer having same delay. If both the NOR gate and multiplexer having different delay, that's why I am going to write this number 1, number 2, number 1, number 2. So this is nothing but NOR number 1 plus again this will pass from this multiplexer. So plus multiplexer number 1. Mux number 1 plus mux number 1 plus now after this multiplexer 2 delay plus mux number 2 clear. How much delay you will get? Why? This NOR is nothing but 2 nanosecond and this is nothing but 1.5 nanosecond plus 1.5 nanosecond. What answer you will get? 2 plus 3 5 nanosecond. Clear this thing? So in first case, when we are considering t as 0 and input is in your hand, maximum delay can be provided 5 nanosecond. More than 5 nanosecond cannot be possible. Clear this thing? Now second case number 2. Second case. Which second case we can consider? Second path will be created when t is equal to 1. So case number 2, if t is equal to 1. Okay. Now if t is equal to 1. Now if t is equal to 1, what will happen? If this t is equal to 1, this is 1. Then what will be these? This will be 0. This will be 0. Now if this is 1, this will be selected. And if this is 0, this will be selected. So your path will be like this. Clear this thing? Now if you are going to provide as and this is going to change, miss one NOT gate. So what will be the output here? Output will pass first from NOT gate. So your output will pass first from this NOT gate, then pass from this multiplexer, then pass from mux number 1, then pass for mux number 1. When you will get this output, this is 1 nanosecond and this is 1.5. If you are considering this is x, this x you will get at 2.5 nanosecond. But you have provided this p at 0 nanosecond. And if you are providing p here at 0 nanosecond, according to this output can be changed at 0 nanosecond. And this delay is 2 nanosecond. And again this input is going to change. Then again output can be changed. So what can be the final stable output after this? So this x you are receiving here at 2.5 nanosecond and this p already you have received at 0 nanosecond. Then after this delay you will get here x. So this x you will get 2.5 nanosecond plus this delay. This is nothing but 4.5 nanosecond. And when you will get this x at output after this delay, this is 1.5 nanosecond. 4.5 plus 1.5 is 6 nanosecond. Clear the thing? So what I can write, this is the first gate, this is the mux number 1, this is the NOR number 2 plus NOR number 2 plus mux number 2 plus mux number 2. What can be the output y? What can be the output y here? NOT gate is 1 nanosecond. This is 1 nanosecond. Mux is 1.5 nanosecond. This NOR gate is 2 nanosecond plus 1.5 nanosecond. What will be the answer? Total delay 2 plus 3 plus 1 6 nanosecond. Which one will be the more? Which one? You can say this is y1 and this is y2. Which one will be more 6 nanosecond? So what will be the maximum propagation delay? 6 nanosecond. Clear? So first you have to find out in combinational circuit what you have to do. Always examiner will target maximum or critical path delay. These two what they will ask, or worst case delay. So they can use three names, either maximum propagation delay or they can use critical path delay, or they can use worst case delay. These three questions they can ask you. All these three things are same. What you have to do in combinational circuit, either it can be by logic gate, either it can be by a multiplexer, or it can be by a multiplexer and logic gate. This is the best circuit. In practical life, we will use multiplexer as well as logic gate kind of combinations. So this kind of questions, maximum time they can ask you. What should be your approach? First thing, this is the important thing. Just this thing, From this part you have to start. How many number of path? Number of path can be single, number of path can be more than 2, number of path can be 2, number of path can be 3, 4, 5. So first you have to find out number of path, then you have to find out which path is going to provide you maximum delay. Clear this thing? Examiner will not ask you here minimum delay. If examiner will ask you what is the minimum delay, what is the minimum delay, then I am telling nothing is going to be changed in this circuit, nothing, everything is 0, then after everything is 0, suppose, then what will be the minimum propagation delay? 0 nanosecond. So examiner will not target minimum propagation delay. Yes, examiner can ask you here, if you have two paths, in which path you will get minimum delay and what is that minimum delay? In two paths they can ask you the minimum path. Okay, but they cannot ask you the minimum delay because minimum delay answer will be 0 nanosecond. Clear this thing? Nothing is going to be changed in this circuit. The answer will be 0 nanosecond. That's why examiners are interested in always maximum propagation delay. Clear this thing? I hope now this thing is clear to all of you. Clear? Now the next question I am considering. Just confirm me this thing is clear or not. Just confirm me this thing is clear or not. This is a good quality of question. Get 2016. Now I am considering next question. So only one thing you have to remember if you will get delay question from combinational circuit. So this is the important thing. First you should think how many number of paths are present. Easily now within 30, 40, 50 seconds or 1 minute easily you can solve. Okay. So this starting point is very important. Sir, how to start? How to start and how to think the question. How to think. Okay. Now I am considering next question. Okay. Everybody just confirm me. Now my next question. Can we implement, if you have studied my previous classes, to implement any Boolean function, which one is the best circuit combinational multiplexers? Now my question, can we implement multiplexer or demultiplexer, this kind of things can we implement? Suppose I am asking multiplexer or demultiplexer by decoder. This is my question. By decoder. Can we implement multiplexer or demultiplexer by decoder? Okay, this is a previous year GATE question I am considering. Again GATE 2016. Okay, now the next question. Here one 2 cross 4 decoder is given. 2 cross 4. This is 2 cross 4 decoder. How many input here? 2 input. This 1, 2. And how many output? 1, 2, 3 and 4. This 4 output was given. Input is C1 and C0. This is C1 and C0. Output is, this is output 0, output 1, output 2 and output 3. This 4 output has given. Here, this is a buffer, and this is a buffer. 4 buffer examiner have considered. 4 buffer. Okay, now this Q3 is connected to this buffer. Q2 O2, this output 2. This output 2 is connected to this buffer. This output 1 is connected to this buffer and this output is connected to this buffer. Okay, this circuit is given and all having input. This input is P. This input is Q. This input is R. And this input is S. PQRS. This 4 PQRS are given. This is a 4 buffer and this all the output is tied. Together and this output is Y. This circuit is given. And this buffer is nothing but tri-state buffer. This is tri-state buffer. Tri-state buffer. In previous classes already I teach you what is the tri-state buffer, but again I am going to tell you. Now you will get here tri-state buffer. Now I am asking you the question, the functionality of this circuit. Is 4 options I am going to provide you. First, 2 cross 1 multiplexer. This is the first option. Option B, 4 cross 1 multiplexers. Option C, 7x1 multiplexers, and option D 6x1 multiplexers. So what is our target? Can we implement multiplexer, not demultiplexer? Okay, can we implement mux by decoder? If you want to implement multiplexer, but if you don't have multiplexer, but you have decoder, then can you implement? This question has been asked directly in GATE exam, but way is different. So first you should know what is the tri-state buffer. First you should tell me what is the tri-state buffer. Tri-state means output can be 0, output can be 1, or output can be no data. So what is the tri-state buffer? Suppose if I am going to assume A and this is B, if B is equal to 1, means if this B is 1, you can say this is switch, then A will be pass at output, then output is equal to A. This you can say output. Clear? Now if B is equal to 0, then what is the output? Here output will be, if A is 0, output is 0, A is 1, output is 1, if B is 1. Now if B is 0, then what is the output? No data. So here output is no data. You cannot say 0 or 1. No data means high impedance state. This is called high impedance state. Either you can say high impedance state or you can say no data. Clear this thing? Now you can see this is the decoder circuit. In decoder circuit only either the 0, 1, 2, 3. Only one output you will get at one time. It means out of this 4 tri-state buffer in one time, only one buffer will work. And if one buffer will give you output, remaining 3 will not give you output. So this, if you are going to tie all the output, it will not reflect to the output. So can we tie it? You can tie this. Why you are going to tie 4 output? In digital we cannot tie the output of any logic gate, but here you can tie, because if this having data, this having no data, it is not 0, this is no data. Clear? So only one data you will get, and that data will be at output. So can you solve this? If C1 and C0, can I write directly C1 and C0, and can I write Y? This C1, C0, 0, 0, 0, 1, 1, 0 and 1, 1. Can I write? So if this is 0, 0, this line will be activated, this line be activated, means this tri-state buffer will be activated, output will be P. So Y will be P. So here Y will be P. So this P will be at output. And that will be decided by C1 and C0. If C1 and C0 is 0, 1, then what will be output? Q will be at output Q. Then if this is 1, 0, this will be activated and output will be R. And if this is 1, 1, then this output 3 will be activated and output will be S. Anybody can say what will be the answer? What can be the answer? This circuit you can written. This circuit means, can I draw like this? Like this? This is a 2 selections line. Which selections line? C1 and C0. So this is 2 selections line, S0 and S1. This is C1 and C0. How many input here? 4 input. 1, 2, 3, 4. And 4 input is nothing but P, Q, R, S. This is P, this is Q, this is R, this is S. And what will be the P, Q, R, S? You can say this P is connected to this 0, means 0, 0. So this will be 0, I0. This is I1, I2, I3, and this is the Y. So this both circuit output will be as it is, same as it is. You can check if C1, C0 is 0, 0, output will be P, 0, 1, Q, 1, 0, R, and 1, 1, S. What is this circuit? 4 cross 1 multiplexer. This is nothing but 4 cross 1 mux. What will be the answer? 4 cross 1 mux. This is a very good level of design question. In a college lab, they can ask you this kind of question. Your logic will be very much improved. But they are asking this kind of question in GATE exam. Clear this thing? They are asking this kind of question in GATE exam. Clear? So this is the circuit. You are going to implement multiplexer by using decoder. Only decoder and 4 tri-state buffer is required. You can implement 2 cross 4 decoder to 4 cross 1 multiplexers. Clear this thing? I hope this thing is clear to all of you. Okay, now the next problem. So here answer is 4 cross 1 multiplexers. This is a very good level of design question. Okay, now the next question. Okay, now the next question we are targeting. Okay, now just note down the next question again. Here just note down next problem. Okay, and this problem is again from GATE 2017. GATE 2017. Okay, now here one gate is given, one more gate is given, and one more 3 gate is given in this way. Okay, now here 2 output can be possible, either normal and bar. This circuit is buffer as well as inverter. This is P, this is Q, and this is R. P, Q, R. Okay, now here one AND gate is given, here one AND gate is given, and here one AND gate is given. 3 AND gate is given, and this AND is connected to OR. This AND gate is connected to OR gate. Okay, this circuit is given, and this output is nothing but function F. Okay, now this is AND. Like this. Clear? And now here this all we can connect like this in this way. After program, and all are having connected with programmable switch. This circuit is given. Clear? Now, and here connections is, you can say this one is P, this is P bar, this is Q, Q bar, this is R, and this is R bar. Can I write? Here P is going to generate P and P bar, Q and Q bar, and R bar. Now some programmable switch are given. Here this is connected, here this is Q bar is connected, and here P bar is connected. So these 3 are the connections available here. Again this is connected. Okay, and here Q is connected, and here this P bar is connected, and now in last this R is connected, and second Q bar is connected, and the last this P is connected. These are the connections. Anybody can say from which topic this question has been asked? In this topic this question has been asked. You are going to see if this is nothing but a programmable switch structure. This circuit is called, here examiner have provided, this is a PLA, programmable logic array. So there are different kinds of, already we have studied PROM or ROM. So different kind of structure are available. So generally 3 structure can be possible. First I am going to tell you some theory, then we will jump on this question. So already we know AND array and OR array. 2 array can be possible to implement any SOP. AND array and OR array. So here AND array is fixed and OR array is fixed. If both is having fixed, that circuit is generally called basic SOP. This is the standard SOP. If both having fixed. Okay, now if this AND array is fixed and if this OR array is programmable, then what you can say, already we have studied, this is nothing but PROM or ROM. You can say, either you can say ROM or you can say PROM. The actual name is PROM. The AND array structure is nothing but a fixed means decoder circuit, and this is having programmable. One more structure can be possible here. This part can be programmable and this part can be fixed. This can be also possible. One more thing can be possible. This thing can be programmable and this thing can be programmable. This 4 kind of structure can be possible for AND or array. Both will be fixed, both will be programmable. AND array will be fixed, OR array will be programmable. AND array will be programmable, OR array will be fixed. So this programmable generally we call this is PLA, programmable logic array, and we will call this is PAL, programmable array logic. all, you can say this all, either you can say PLA, you can say all this is programmable logic array, because this is programmable, both having programmable. Clear this thing? So this kind of structure can be possible. Already we have studied this kind of structure. Now here if you can see this, and this part is fixed, and this initial part is programmable, okay. So let's see what will be the output of this circuit. Okay, I am going to provide you 4 boolean function they have provided us. Clear this thing? So this kind of question in GATE exam they can ask you. This is GATE 2017 question. Clear? I hope this thing is clear to all of you. Okay, this is the actual name. This is ROM, or actual this name is programmable read only memory. This is programmable array logic. This is programmable logic array. But generally we call this is a PLA, programmable logic array. Okay, so examiner either will tell you PLA or will tell you PROM. These two names generally examiner will use. Clear? So this PLA is given. What is this F? So we have to find out F is equal to question mark. Okay, 4 options they have provided. Okay, I am going to provide you 4 options. First option, P bar Q bar R plus P bar Q R plus P Q bar R bar. This is first option. Option number B, P bar plus Q bar plus R. This is first term. P bar plus Q plus R. This is second term. And P plus Q bar plus R bar. This is third term. Now option C. P bar Q bar R plus P bar Q R plus P Q bar R. This is option C. And what is the last option? You should try to solve and tell me the answer which is the correct, A, B, C or D. And last option they have provided us P bar plus Q bar plus R. Now the second one is given P bar plus Q plus R, and third one is given P plus Q bar plus R. These 4 options they have provided us. What can be the answer? You can see here 2 options. This is nothing but SOP. And this is POS. So examiner can provide you in any form. And here how many variable function? This is a 3 variable function. And in all the terms, all 3 variable are present, means complete form, canonical form is given here. So here 2 SOP and 2 POS, canonical form they have provided us. Okay. Now what will the output? This part is saying this will be AND, and this part is saying this will be AND. So directly you can write the answer. What can be the answer? This is connected with here P bar, this is connected with Q bar, and this is connected with R. P bar Q bar R. What will be the second function? This is nothing but P bar, this is nothing but Q, and this is nothing but R. P bar Q R, and this one is P, and this is connected with Q bar, and this is connected with R. And this, all these 3 having OR. So what will be the output function? F is nothing but P bar Q bar R plus P bar Q R plus P Q bar R. Yes, the first options P bar Q or P Q bar R. Okay, this option is okay, P bar Q bar R plus P bar Q R P Q bar R. Okay, so this C is the correct answer. Clear? Now here if examiner, suppose examiner provided in this way, or then this will be OR, and if examiner are going to provide this is AND. So what does this mean? It means all these 3 is OR then AND. So we have to concentrate on these things. In PROM, if you remember, in PROM after decoder we use OR gate. First one is the AND, second one is the OR. Okay, so here if you can see, this is the AND structure. In previous cases, if this is AND, this is AND, and this AND structure is programmable. So here this OR, and this was your OR gate. So this OR gate was fixed. but this AND structure are programmable. This AND structures are programmable. So AND structure can be also programmable, or structure can be also programmable. So two names you should remember. If OR structure are programmable, that is PROM. If AND structure are programmable, that is PLA. If both are programmable, you can say that is PLA. Clear this thing? Now the next problem. This is very simple question. In GATE exam, I hope you can solve easily within 30 seconds. Easily. This kind of question, but you should know. This standard circuit. Okay. First, you should know what is this exactly. Okay. Now the next question. Okay. Now the next question. From GATE 2018, I am considering one question from multiplexer. Okay, this question is asked in GATE 2018, and from the multiplexer. This is very simple question. Multiplexer is very easier. Only you have to process. Two multiplexers are given. Now you can see single multiplexer question they are not going to ask you. Generally they are asking two multiplexers question. Okay, now, and here this is I0, I1, I2 and I3. Here this is I0, I1, I2 and I3. These two multiplexer are given. Both will having 4x1 and 4x1. Here two selections line. This is S0 and S1. Here two selections line. This is S0 and this is S1. Okay. Now here 4 input. 1, 2, 3, 4. Okay. Now these two are connected with a VCC. Plus VCC means 1, logic 1, and this I0 and this I3 is connected to ground. Ground means 0. So sometimes they can also provide you VCC, VDD plus 5 volt, that is logic 1, and 0 means logic 0. Clear this thing? Now this is U and this is V. And now this output is connected to I0 and I1. This output is connected to I0 and I1, and these two are connected with the ground. Ground means 0. What is the output function? Then output this F in terms of UV, and this is WX. Function of U, V, WX. What is this? You have to find out this function. Very easy question. First you have to solve this circuit, then you have to solve this circuit. How you can solve? If this is 0, 0, directly this function you can write. What you will get this function? Can I write? U bar V bar 0, 0 will pass I0 is 0, multiply with 0, plus U bar V multiply with I1 is 1, plus U V bar multiply with 1, I2, plus UV multiply with 0. So this term and this term will be cancelled. 0. U bar V plus UV bar means UV XOR gate. So what you will get here? U XOR V. Clear this thing? Now what will be the output? What will be the final output? Can I write directly? W bar X bar, and that will multiply with U XOR V. Plus what will be the second function? W bar X multiply with again same function U XOR V. Can you write in this way? Like this. This will be the answer. Clear? And remaining two terms multiply with 0. Now you have to simplify. Can you write this? W bar is the common term and U XOR V is also a common term. Can we consider? This and this is the common term. W bar X was also present. No? This was X. Okay. W bar U XOR V you can consider common. X plus X bar. And X plus X bar is nothing but 1. What will be the answer? W bar U V bar plus U bar V. Now you can also open W bar U V bar plus W bar U bar V. You can write in this way. Okay, you can write in this way. Clear? This will be the answer. Clear this thing? Now the next question. So just you should feel, if examiner will ask you any kind of multiplexer question, just you have to process normally. Just you have to process normally. So multiplexer is very easier topic. Okay, now the next question I am going to target. Clear this question? Okay, now the next question. Now the next question. I hope ki now you are very much comfortable in. Already we have discussed many good quality of question in delay question in adder circuit. I hope you are expert in adder. I hope you are expert in multiplexer. I hope you are expert in this decoder circuit, encoder circuit like this. Okay, some more question I am going to consider. Next very good question. Next one very good question. Okay, from gate one more very good level of question. Again I am going to consider one good question from gate 2015. From gate 2015. From gate 2015. Okay, now gate 2015. Just note down. Just note down. Here two multiplexers, sorry, two decoders are given. 2 cross 4 decoder. 2 cross 4 decoder. One more decoder is given. One more decoder is given like this. This is again 2 cross 4 decoder. Clear this thing? Now here this is active low. This is active low. This is first output, second output, third output, fourth output. This is first, second, third and fourth like this. Okay, now this is 0, 1, 2 and 3. This is 0, 1, 2 and 3. Okay, now this output they have provided Y0 bar, Y1 bar, Y2 bar and Y3 bar, and this is nothing but Y4 bar, Y5 bar, Y6 bar and Y7 bar. Y7 bar. Okay, Y7 bar. Now here two input, here these two are the input. These two input they have provided. This is 0, this is 1, this is 0, this is 1. Please carefully, this is 0, this is 1, this is 0 and this is 1. Okay, now this both 0 are connected with same, both 0 are connected and they both 1 are connected with same like this. Okay, now and this 1 and 0, this 0 is connected to R and this 1 is connected to S. Clear this thing? So these two are the input and here this is active low enable, active low enable. You can say this is enable bar and this is enable bar. Clear? This is active low enable and here one OR gate is given. One OR gate is given like this. One OR gate is given. And this is connected with P and second input is Q like this. P and Q. P and Q. Okay. Now the next one. Again here one OR gate. Again here one OR gate. And this is again connected with same P. Same P is same but Q is complement. Q is complement. Q is complement like this. This circuit is given. This circuit is given. Okay. And now what examiner are saying? This circuit is nothing but 1 cross 8 demux. This circuit is nothing but 1 cross 8 demultiplexer. Demultiplexer. Okay. This is nothing but 1 cross 8 demultiplexer. Then what will be the PQRS? PQRS is equal to question mark. If this circuit you want to design as a demultiplexer, 1 cross 8, 1 input, 8 output. So this is the 8 output. Here 1 will be input and 3 will be selections line. 3 will be selections line. But here you are getting input in terms of PQRS. Then what will be the PQRS? 4 options I am going to provide you. First options S2, second D in, S0 and S1. So here 3 will be selections line, 1 will be data. So here in first option P is the selection line number 2, Q is the input data and R is the S0 and S is the S1. Second option, option number B, S1, D in, S0 and S2. Option number C, first data is D in, second one is the S0, S1, S2, S0, S1, S2 and last option is the D in and then S2, S0, S1, S2, S0, S1. Now you have to find out this quantity. Clear this thing? Now again this is a design question. What examiner want to design here? What examiner want to design here? 1 cross 8 demultiplexer by using decoder circuit. So in previous cases already we have seen multiplexer by decoder circuit. multiplexer by decoder circuit. Now again examiner want to design demultiplexer by decoder circuit. Demultiplexer by decoder circuit. So now just listen, you can implement multiplexer by decoder as well as you can also implement demultiplexer by decoder circuit. So this is the question from implementation of demultiplexer by decoder circuit. So here they have considered total 8 output is required for 1 cross 8 demultiplexers. Clear? Now if this is a demultiplexer for 1 cross 8 demux, for 1 cross 8 demux, how many input? 1 is the input, you can say this is data D in. This is the input data and how many output data? 1, 2, 3, 4, 5, 6, 7, 8. These 8 are the output data. These 8 are the output data. Clear? These 8 are the output data. Clear? So these 8 are the output data. So in demultiplexer exactly what happens? What happens? Here 3 will be selections line. This will be, this is S0, this is S1, this is S2. This 3 will be the selections line. Now how demultiplexer will work? If this is 0, 0, 0, this will go to the 0. Suppose this is 0, 1, 2, 3, 4, 5, 6 and 7. So if this is 0, 0, 0, D in will goes to 0, 0, 0, 1, D in will goes to 1. If this is 1, 1, 1, D in will goes to 7. So this thing should be happen. This thing should be happen. But here you can see all are the active low. And they want to design active low demultiplexer. So right now you don't have to concentrate on active low. You can consider output here, here, here and here. You can consider here, here, here and here. So right now we don't have to concentrate on active low and active high. Okay, just we are concentrating on the standard procedure. Clear this thing? So now how to solve this question? How to solve? So when you will get output here, means here 0. When you will get output here, when this will be 0, 0, when this will be 0, 0, when this will be 0, 0. When this is 0, 0, this will be activated, 0, 1, this will be activated, 1, 0, this will be activated, 1, 1, this, sorry, 1, 1, this will be activated. For 0, 0, this will be activated, 0, 1, this, 1, 0, this and 1, 1, this. Now, when in demultiplexer, when you will get output here, when S2, S1, S0 is 0, 0, 0, then input data as it is you will get at output. Okay, so after, okay, now I am going to solve this question. Let's see how. So when you will get here output, what can I write? Can I write directly? So right now I am removing all this bubble like this. And I am considering this is your output. When you will get here output for the active high, because we are expert in active high. When you will get here output, when this R bar S bar. So can I write this function? PQRS, this is R bar S bar. When this is 0, 0, this will be activated. Now when this will be enabled, this is 0. And for this is 0, P and Q both will be 0, 0. So what I can write? P bar, Q bar, R bar, S bar. This is the first function. Now what will be the second? Here, this P and Q will be always same. So can I write again? P bar, Q bar, this is R bar, S. Can I write? Because when this is 0, 1, this line will be activated. For the next function, this P bar, Q bar will be same. This is R, S bar. And what is the next function? P bar, Q bar, this is R, S. Can I write? Yes. Now what will be for this? What will be for this function? Again, this enable is 0. If this is 0, this will be 0 and this will be 0. So this will be 1. Means Q will be 1. So can I write P will be always 0, P bar, and here Q should be 1. So P bar Q. This is P bar Q. This is P bar Q. This is P bar Q. Can I write? In this way? Now, when this will be enabled, this will be 0, 0. 0, 0 means R bar, S bar. This is R bar, S bar, R bar, S, R, S bar and R, S. Like this. If you will consider, we are considering right now for active high. Okay. What will be this function? This function is S2 bar, S1 bar, S0 bar into D in. Can I write? Here, second function S2 bar, S1 bar, S0 into D in, like this. You will get this kind of function. If you can see first four, this S2 will be 0. And this remaining 4, S2 will be 1. And here S1, S0, 0, 0, 0, 1, 1, 0, 1, 1. then 0 0 0 1 1 0 and 1 1. Now you can see which quantity is here and here different. You can see q. This q, you can see this q is 1 and here 0. This q is here 0 and here 1. So what can I write? Here this q is 1 and here this q is 0. It means this q is S2. So can I write this q is S2? Can I write? What will be here? This is 0 0. Here you can say, okay, sorry, this is 0 and this is 1. Na? We have wrong here. This is 0 and this is 1. So please change this. This is R S bar and this is R bar S. Please change. This is R S bar and this is R S. Because this R is 0 and S is 1. You should write like this. This is 1 and this is 0. And this is S and this is R. So first you should write S then R. So first you should write S then R. Clear the thing? Okay. This we have done here mistakes. Okay. Now, so S is the MSB here and R is the LSB here. So first you should write S bar R. Here S R bar. And this will be same. And here this also you can change. Now, here R bar S bar. R bar S bar. What you can say? S bar is the first quantity. So S you can say is nothing but here S1. Can I say? And what is the R is nothing but S0. So this is the two selection line. Which selections line? Lower side S1 and S0. So this will be nothing but S1 and this will be nothing but S0. Clear? And what is the P here? Sorry, what is the Q here? S2. So this three data already you have find out. And which data is common in all? What will be the last data? S2, S1, S0 into D in. Which data is common? You can say P. P is common in all 8. So P will be data. So what I can say? P will be your data in. P is the data and this QRS is the selections line and Q is the S2, S is the S1 and R is the S0. So what you can say? What is the PQRS is nothing but first data is D in, second data Q, Q is the S2, R is the S0 and the S is the S1. So this will be the answer. D in, S2, S0, S1. Okay. The option D. The option D. The option D. Option D. This is very good level of question. Very good level of question. This is very good level of question. Clear the thing? How to solve this kind of question? Clear this thing? How to solve this kind of question? Clear this thing? How to solve this kind of question? So if reverse question in exam, suppose if I will ask you, implement a demultiplexer by decoder circuit. Implement demultiplexer by decoder circuit. So by using this, you can easily implement. But in GATE exam, this thing is given in terms of active low. Meaning is same for both. Representation is different. So for either you can solve our active low or active high. Both will be same. Here you are considering this is Y0. If you can put here bubble, you can say this is a Y0 bar. Both will be same. Both will be same. So examiner have provided you here. This is bubble and this is Y0 bar. So I have cancelled this bubble and I am going to write this is nothing but Y0 like this. And this is Y1, Y2, Y3 and this is Y4, Y5, Y6 and Y7. Clear this thing? So can you solve? So right now we have seen two kinds of problem. One problem multiplexer by decoder and second problem demultiplexer by decoder. Clear this thing? Now the next question we are going to target. But in GATE exam, they will not target reverse design question. They will target forward design question like this. They will provide you the design and they will ask what is the output. This is very easier things. This is very easier thing. Clear the thing? So anybody have any doubt? Ask me. Just confirm me. Just confirm me this thing is clear or not. Just confirm me this thing is clear or not. I promise you, if you will follow my all the classes thoroughly from the first classes to last class, definitely you can get a better marks. Definitely you will get a better marks. Clear? Next question. Okay, next question I am going to target. Next question. Okay, now from GATE 2014, from GATE 2014, okay, and very simple question. Two multiplexer is given like this. This is 0 and this is 1. One more multiplexer is given like this. This is 0 and this is 1. Okay, this input is W and this is again connected by NOT gate, and this output is connected to 0, again this is connected with NOT gate, like this. Okay, and this is S1 and this is S2, and this is the final output. This is the final output function f. Function f. Clear? What will be the function f? What will be the function f? 4 options I am going to provide you. First option, f is equal to W S1 bar S2 bar. Option B, function f is equal to W S1 plus W S2 plus S1 S2. Option C, f function is equal to W bar plus S1 plus S2. And option D, the function f is equal to W XOR X1 XOR X2. Okay, these 4 options they have provided you. So easily you can solve. What will the first answer? This is S1 bar into W plus S1 into W bar. What you can say? This is nothing but S1 XOR W. S1 XOR W. What will be the this output function? This S2 bar, this multiply with S1 XOR W plus this as it is S2 multiply with this bar. This bar means S1 XOR W whole bar. What you can say? A bar B plus A B bar. What you can say? All this XOR gate. So can I write X2 XOR X1 XOR W? This will be the answer. All these 3 having XOR gate. All these 3 having XOR gate. This question already in last class we have discussed, and in many times this question has been asked. This question has been asked. Clear? Now here, suppose for example, clear the thing? Okay, now this thing can also be connected here. This thing can also be connected here, and they can also provide here S2 like this. Like this. So different kind of representation can be possible. Clear the thing? Okay? Clear? So what will be the answer? All these 3 having XOR gate. Now the next question. Now the next question. Now I hope you are very much comfortable in all this logic gate, delay questions, adder circuit, multiplexer, decoder, demultiplexer, and all kind of these things. Okay. Now I hope you can solve many number of questions. Okay. Now one more question I am considering. Suppose for example, one more question I am considering. Suppose we having a multiplexer, this kind of multiplexer. Suppose this is a multiplexer like this. Okay, and this is the output. This is the output, and if here suppose I am considering this is connected. This output is connected to again here. This output is connected to again switch, and this switch is like this. And suppose this is 0 and suppose this is 1, like this. Suppose this is 0 and suppose this is 1. Suppose this 0 is connected to 1. Suppose this and this 1 is connected to 0. Suppose for example like this, and this is the output. This is the output. And this switching delay. And suppose if I will say this switching delay is equal to 5 nanosecond. Switching delay is 5 nanosecond. What can be the output of this circuit? What can be the output of this circuit? Switching delay is 5 nanosecond. What can be the output of this circuit? Clear? This is nothing but 2 cross 1 multiplexers. This is nothing but 2 cross 1 multiplexer, and you have designed by a switch. You can say this is the analog multiplexer. This is not a digital multiplexer. Only switch is present inside the multiplexer. Now if I am going to consider output initial 0, initial this was 0, so this was 0, this is selections line. You can say this is selections line. Okay, when this is 0, this line will be selected. Output will be 1. Output will be 1. Now this output will be 1. If this is 1, this is connected to 0. So again switch will move to 0. After how much time? 5 nanosecond. So after 5 nanosecond, this will reach to 0. This is 5 nanosecond. Again the switch is at position 1, okay, and output will be 0. Again if this is 0 selections line, if selections line is 0, what will happen? You can remove this, na? If selections line is 0, you can connect like this, okay? Now only if this selections line is 0, again this one will be selected, again output will be 1. After how much time? 5 nanosecond, and again you will get this kind of output. This is nothing but a square wave generator. We are going to generate a square wave. We are going to generate here a square wave. Then what will be the output? Output will be a square wave. And what is the frequency or time period of this square wave? Time period is nothing but 10 nanosecond, and frequency will be 1 upon 10 nano. This will be the answer. This will be the answer. Clear this thing? This will be the answer. So by using this 2x1 multiplexer, just you can connect output to the selections line, and 0 is connected to 1 and 1 is connected to 0, means this is ground and this is supply. This is plus VDD. You will get a square wave. You will get a square. This is a previous year gate question. This is a again previous year gate question. What will be the output? You will get output is a square wave, and square wave time period will be 10 nanosecond. 10 nanosecond. Clear this thing? 10 nanosecond. And square wave output will be 10 nanosecond. Clear this problem? Clear this problem? Okay. Now, so generally we have targeted all category of problem. Already decoder and encoder question already in previous sections I have already considered. Okay. I hope you can solve. You can solve many number of question. According to me, if I will see all the previous year question, you can solve any question. I don't feel you will get any doubt in any question. One more question I am going to consider. One more question. Okay. If anybody have any doubt, just ask me. Yeah, Sanjana is saying, sir, your teaching is awesome. Thank you, Sanjana. Sir, please 2 hours of classes. Do not worry. I will complete all the parts. If you can see my all the lessons, you are very much comfortable are in digital. I hope ki till combinational circuit you can solve any question. If you will get any doubt, you can ask me in my telegram groups. Okay. Clear? One more question I am considering. Just note down next question. But one thing all of you have to remember, all the classes are linked. So at least you have to study before going to start my any classes, previous classes. Okay. At least you have to study. Next problem. Okay, next problem I am going to consider. Okay, this multiplexer is given 4x1 mux. This 4x1 mux is given. Here this is 4 input, 1, 2, 3, 4, and this is 1 output. This is the output, and 2 selections line. This is S0 and this is S1. And this is A and this is B. So A and B is given. Here this is 0, 1, 2, 3. Always you have to concentrate on this. Sometime examiner can provide you 3 upper side and sometime 3 bottom side. This thing generally we follow. This is MSB, this is LSB, but examiner can change this also. Sometime they can provide you 0 here, means S0 and S1 here. You have to concentrate on this first. Only in multiplexer, in this point only a student can get wrong. Otherwise 100% answer easily you can find out. Okay, so error you don't have to do. Here this is C and here this is D. Now here this is again connected with NOT gate. This is NOT gate and this is C. And here we are again going to connect one AND gate. And this is connected by 2 bubble AND gate, and this is C and this is D. So now you can see this is 4x1 multiplexer. Here A, B, C, D. How many variable? 4 variable. So some 4 variable function you can also implement by 4x1 multiplexers. Okay. So what is the output? 4 options. This output function f A, B, C, D. Okay. 4 options I am going to provide you, and you have to tell me the answer. Function f is equal to mean terms of 0, 1, 3, 5, 9, 10 and 14. And second, B, option B is given function mean terms of 2, 3, 5, 7, 8, 12 and 13. And option C is given, function f is equal to mean terms of 1, 2, 4. 1, 2, 4, 5, 11, 14. 5, 11, 14 and 15. And what is the last option? Option D, function f is equal to mean terms of 2, 3, 5, 7, 2, 3, 5, 7, 9 and 12. These four options they have provided us. So directly you can write, directly you are expert in canonical form, you are expert in SOP. All the four options they have provided here. Mean terms means SOP. Directly can I write? Yes, easily you can write. This is A bar, B bar. And that will be multiply with 0 means C. A bar, B bar, C plus A bar, B, 0, 1. And that will be multiply with 1, 1 means D. Plus what is the next term? A B bar, 1, 0, A, B bar. And that will be multiply with C bar. And this is C bar. And what is the last term? This is nothing but C bar, D bar. So what is the last term? A dot B multiply with C bar, D bar. C bar, D bar. Now you can easily write from here, you will get A 0, 0 and C is 1, don't care. From here, this is 0, this is 1, C is don't care and this is 1. From here, this is 1, this is 0, this is 0 and D is don't care. And from here, this is 1, this is 1, this is 0, this is 0. Here you will get two terms, 0, 0, 1, 0, 2 and 0, 0, 1, 1, 3. From here you will get two terms, 0, 1, 0, 1. That is 5, 0, 1, 1, 1. That is 7. That is 7. Easily you can write. You should be expert in this canonical form. 1, 0, 0, 0. That is 8. 1, 0, 0, 1. That is 9. 1, 1, 0, 0. That is 12. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. All having 7, 7, 7, 7, 7. Okay. You can see 2, 3, 5, 7, 8, 9, 12. 2, 3, 5, 7. 2, 3, 5, 7. Okay, last one I think wrong, na? 2, 3, 5, 7, 8, 9, 12. Here 8 was also present. 5, 7, 8, 9, 12. This is 8, 9, 12. Okay, just correct the last option. And answer D will be the correct answer. Answer D will be the correct answer. Answer D will be the correct answer. Easily you can solve. Examiner can provide you any logic gate here. Anything they can provide you. Just here to process. Clear? One more question I am considering. Okay, one more question I am considering. Clear this? Now, clear this problem? Okay, one last question, and that I am going to consider from the K-map, and logic, from K-map and truth table, and this is very good question. Next problem. Again, this is previous year gate problem. The minimal function then that can be detected divisible by 3. So we have to design divisible by 3. 2 BCD. Divisible by 3, 8, 4, 2, 1 BCD code. This you have to implement, and you have to implement in terms of D8, D4, D2 and D1. In terms of these, suppose you can assume A, B, C, D or W, X, Y, Z. So they have provided you D8, D4, D2, D1. In terms of this, you have to implement a function. So you have to find out function f D8, D4, D2 and D1. And they want to ask you minimal function, minimum SOP you have to find out. The input code is BCD and your result should be divisible by 3. Okay, 4 options they have provided us. Directly how to solve this kind of question. So what is your input? Input is 8421 BCD. This is the input. And this is the output. What is the output? Divisible by 3. So first can I write this is D8, D4, D2 and D1. Okay, now this can be 0, 0, 0, 0. This can be 0, 0, 0, 1. This can be 0, 0, 1, 0. This can be 0, 0, 1, 1. This can be 0, 1, 0, 0. This can be 0, 1, 0, 1. This can be 6. This can be 7. This can be 8 and this can be 9. Can you say? BCD is only defined from 0 to 9. What can be the output? 0 is divisible by 3. Yes. 0 is divisible by every value. 1 no, 2 no, 3 is divisible by 3, yes. 4 no, 5 no, 6 yes, 7 no, 8 no, 9 yes. Now if you want to put this data in K-map, this data is K-map. This is the very important thing. What you will consider after 9? What you will consider after 9? What you will consider after 9? Just you should know in previous classes I already tell you the exact meaning of don't care. If input is not present, then output you can consider anything. So here if you are going to write for this decimal quantity 0 to 9 for 10, input is practically not possible. So for 10, what will be the result? What will be the output? You can consider anything, because 1010 input you cannot provide. So output will be not generated. So you can consider any output, either 0 or 1. That is your choice. Clear this thing? What is the meaning of don't care? If you are not going to provide that input, for that input, what output you can consider anything. Because this input 1010 you cannot provide in this circuit, because the data is BCD code. So input 1010 or 1011 till 1111 input you are not going to provide, and if you will not provide this input, the result for that you can treat either 0 or 1, you can consider as a don't care. So remaining all data you can consider don't care. Clear this thing? Why you are considering remaining is don't care? Then what will be the output? Just minimal function you can find out by using K-map, like this, by using K-map. And this is nothing but D8, D4, this is D2, and this is D1. This is 0 0 0 1 1 0 and 1 1. This is 0 0 0 1 1 0 and 1 1. Now you can put 1 0 0 1. This is 1 0 0 1. What will be the next data? 1 0 0 1. Next is 0 0 1 0. 0 0 1 0. What will be the next? 0 0 1 0 0 1. Don't care. This is 0 1. This is don't care. 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 And this is don't care. Which group you can form from here? You will target how many number of 1, 2, 3 and this 4. If you will target this one, this group can be formed. Clear thing? If you will target this one, this is a single one. Okay. Now, if you will target this one, this can be this group. And if you will target this one, this can be this group. You can also implement divisible by 2. You can also implement divisible by 4. Any function you can implement. You can also implement even number detector. You can also implement odd number detector. Anything you can implement from here. Only just you have to write down the output, and just you have to find out minimal function by using K-map. What can be the answer? Function D8, D4, D2, D1 is equal to, what can be the answer? What you can write this? This is nothing but D8, and here common term is D1. Here D1 plus second term, what you can write? This term you can write here D4, and from here you can write D2, D0 bar. What will be the next term? From here you can write common term is D4 bar, and from here D2, D1. And what is the last term? Last term is single. You can write D8 bar, D4 bar, D2 bar and D1 bar. Like this. This will be the answer. Clear? Just I am going to check the option. Okay. D8, D1, yes, plus D4, D2, D4, D2, D1 bar, D4. Okay, anything wrong here? We can make this group, this one. For this one, we can make this two group. For this one, we can make this only this two group, na? And for this one, we can make single group. Okay, just I am going to check the answer. Okay, D8, D1, D4, D2, D1 bar, this, and the third term is D4 bar, D2, D1, and this. Okay, this was wrong. This was wrong. No? Second term here, this is D4, D4. This is D1. Sorry, this is D1. No? This is D4 and D2 and D1 bar. Yeah, correct, correct. Everything is correct. Okay, just you should correct. This was not 0, no, this was 1. Clear the thing? So here you can also implement, if examiner will ask you even number detector. So even number of output you will get 1, remaining will be 0. So you will get a function. Odd number detector, you can find out. Majority input detector, for 4 input they will not target majority input. For 3 input they can also ask, for 5 input they can ask you majority input detector. So if you know any input and output function, you can implement any circuit. So if you want to write a block for this circuit, this is the 4 input, 1, 2, 3, 4. And this 4 input is D8, D4, D2, D1. And here only 10 input you can provide, 0, 0, 0, 0 to 1, 0, 0, 0 to 9. And this is the output. And inside this you will get this logic gate, and this circuit you can implement either by decoder or by multiplexer or by logic gate. That is your choice. Earlier we have studied everything is implemented by NAND gate. Now that is our choice. If I want to implement this by multiplexer, we can implement this by multiplexer. You don't use here NAND gate. You can implement this function by multiplexer also. Clear the thing? So in real life, we don't use NAND gate. Now we are going to implement circuit by multiplexers. So inside of this, you can implement this also by either decoder or multiplexers. Clear the thing? So I hope you can solve any kind of question. You can implement any kind of functions by using this truth table and by using this K-map. I hope you are very much comfortable in K-map. I hope you are very much comfortable in logic gate, bubble gate as well as XOR gates. I hope you are very much comfortable in adder circuit as well as delay problem. I hope you are very much comfortable in decoder circuit, active low and active high, as well as encoder, as well as demultiplexer, as well as multiplexer. I hope now you are very much comfortable in code converter also. Clear the thing? So I have touched all the topics. Clear? So from next session we will start sequential circuit, and sequential circuit my first topic will be latches, and that will be very, very important. If you will attend my first classes from the sequential circuit, definitely you will be very much comfortable in sequential circuit. Clear? If anybody have any doubt, just ask me. Otherwise I am going to stop today's session. Okay, tell me if anybody have any doubt, and everybody please like the session. Okay, if anybody will get any doubt, just ask me. Okay, otherwise from tomorrow again we will start. Please tell me. From tomorrow we will start sequential circuit. Okay, from tomorrow we will start sequential circuit. You should try to solve all the previous year question. Okay, all the previous year question you should try to solve. Okay, no doubt. Okay, thank you and bye bye. So tomorrow at same time again we will start sequential. Okay, thank you.